So, hello everyone. My name is Marta Boscariol. I'm from the University of Turin, and I'm here to present this paper in collaboration with my research team. And this paper investigates the potential of integrating IoT sensors data streams into building models and their visualization, focusing on the topic of indoor environmental quality. So this research originates from an attention towards sustainability goals in the built environment. In fact, it focuses on reducing greenhouse emissions attributable to buildings, as mentioned in the European Green Deal. It also aims at detecting improper construction management to reduce waste expenses and energy consumption. And it focuses on the influence of human presence on building performances and on indoor environmental quality. Integrating IoT devices, therefore dynamic data, into university buildings drives us toward the concept of a smart campus. And moreover, managing extended built assets implicates an intrinsic heterogeneity and a multiplicity of actors involved. For example, students, teachers, personnel, facility and energy manager, etc. According to system thinking, we can see this as a complex adaptive system. And we think, or at least it's clear that employing digital tools like BIM, GIS, and IoT devices might foster the creation of a digital twin for efficient building management. It might allow tailored solution for each group of stakeholders, such as data integration and indicator visualization and so on. In our case, a digital shadow has been developed, therefore information flows are only unidirectional from the physical to the digital asset. In a previous phase of our research project, BIM and GIS technologies have been exploited to create an asset management system. Its aim was recollecting and interlinking all data useful for managing the real estate assets of the University of Turin, making them available for an easy and quick navigation. Then in a second phase of this project, which is the object of this paper, of course, we aimed at integrating into these asset management system those data coming from a bunch of IoT devices newly installed in some university buildings. These devices collected data on indoor environmental quality. So the aim of the research is therefore the creation of a digital shadow exploiting data connection from sensors to our digital model, stepping towards the implementation of digital twins. So as stated before, our research at the University of Turin focuses on implementing an AMS to collect and merge data from various university departments, which are then interrelated and made available via dashboard and BI tools. Meschini et al. 2022 outlined the methodology, including data collection, creation of a relational database, BIM modeling, BIM-JS integration, data flow analysis, and dashboard publication. So we can say, or at least we think, that this rigorous methodology ensures the scalability of the platform and its upgradability for implementing additional data types. We are now presenting our pilot case, which is Luigi Einaudi campus. It has been designed by Norman Foster, and it opened in 2012. It covers a surface of around 45,000 square meter, and it hosts around 16,000 users. Since recent analysis revealed a significant impact on university costs, energy efficiency interventions are currently under the lens. And in this campus, the University of Turin implemented the installation of some IoT devices to improve indoor comfort and energy efficiency. They were installed mainly in classrooms to monitor of course, environmental quality. They are called AirCare Pro Plus, and they measure various factors related to air quality, such as volatile organic compounds, CO2, particulate matter, also environmental comfort-related indicators relating, such as temperature or humidity, and also electrosmog. They are 37, and as I said, they are installed in teaching, in areas used for teaching activities, and then we created relationship between the data from the sensors to the existing semantic and geometric data of our 3D model inside our platform. And through the cross-referencing of this data, we managed to understand air quality in relation to the classroom usage. We investigated literature and good practices, as well as regulation, to set some benchmarks on those indoor environmental quality factors we decided to monitor. For example, environmental conditions in classroom. We know that we should prevent overheating in non-heating season and maintain recommended temperature ranges, taking into account that lower temperature, it has been shown how they improve student performance and reduce sick building syndrome. If we talk about CO2 concentration, the higher CO2 concentration level are associated with health issues and decreased academic performance, so we suggest to prevent that with increased ventilation. Now, while also talking about volatile organic compounds, they come from construction and cleaning materials, and they should be screened to avoid harmful exposure. And we should follow the World Health Organization guidelines. Then going to talk about particulate matter and traffic-related pollutants like NO2 or CO. We should also be compliant with World Health Organization guidelines, as these traffic-related pollutants are linked to illness-related absenteeism and asthma incidents on students. We applied then business intelligence solution to monitor these indoor environmental quality conditions in buildings, because business intelligence enables data gathering, analysis, real-time monitoring, or, for example, predictive analytics. The data connection methodologies involves obtaining data from IoT sensors and integrating them in the BI platform. This process ensures we set up ensures regular data refresh and provides a refresh history report for monitoring. In fact, data retrieval and parsing are done using Python libraries such as request and pandas. Then data is stored in a database and loaded into Microsoft Power BI using PyoDBC libraries. And in the end, automation is achieved through task scheduling and automated data updates inside of Power BI. Now here I have a video that shows our initial dashboard, which focuses on monitoring key parameters: temperature, CO2, volatile organic compounds, and particulate matter. In fact, this dashboard shows a floor plan highlighting classroom with sensors. We can then click on the classroom we aim to visualize, and so the data over a week. The study focuses on 3 classrooms, A2, A3, and A4. They are located on the ground floor of the campus. So, as I said, analysis was conducted for a specific week with optimal parameter level indicated on the graph aside the floor plan. And we might say that overlapping different types of data, such as air quality, thermal condition, and scheduling, provided valuable insights. For example, if we want to compare temperature observation, while Class A2 maintained compliance with the limit, A3 and A4 consistently exceeded recommended level, but this might be correlated to room orientation or maybe occupancy. If we talk about CO2 levels, during classes they were always below the threshold, but if we look at classroom A2, while in A3 and A4 they had higher peaks. If we take as an example class A4, we can see that particulate matter values respect limit generally, but sometimes where they have high peak, they correspond to CO2 and temperature and volatile organic compound drops, and this might be related to a better ventilation, probably a user intervention through window opening. So we can assert that this study this study contributes to to addressing the connection between IoT data to our asset management platform, contributing to a smarter and more connected campus. Utilizing digital technologies, particularly IoT devices, offer valuable solution for real estate management, especially for large and complex portfolio. Connecting IoT sample data to BIM models and correlating it inside the platform enable a quicker access to information and strategic decision making for the university administration. With this dashboard, it has been possible to demonstrate to the administration how human presence and external factors impact indoor environmental quality, highlighting the need for monitoring and management. So advantages of connecting data streams to the model include quick association and visualization of environmental quality with diagrams and indicators, while challenges involve managing and interconnecting large data streams, relying mostly on cloud services. So it is clear how IoT devices in building automation can improve indoor environmental quality, occupant comfort, and productivity. On our future research schedule, we would like to explore the European framework for indoor air quality assessment through core indicators, incorporating objective air sampling, occupant feedback, and usage pattern for remedial action. We might also implement machine learning system as they offer opportunities to enhance automation and accuracy in building management based on user behavior and collected data. So that's all, and thank you for the attention.